All right. For the circles, the most important property we learned besides the formula is a line segment from the center to the tangent line is perpendicular to the tangent line. So this is one of the important property we learned in last class. This is called the tangent line. There's one point called tangent point. Then if you connect from the center to the tangent point, and this line will be perpendicular to the tangent point. Right, and the second property is just a formula. We're trying to find the length and the area. Okay, if we know the theta, if we know the radius. So the arc length is theta times r, then the area is going to be half of theta r squared. So theta is in radians. Okay. Now, William, you probably missed the last class. You can look at the emails and let me know. Okay, I have recorded lectures for you if you missed it. Okay, so that is what we learned in the last class. Okay, then we needed to learn one more properties about circles. So this is the center, and take 2 points A and B. We find out, this is point P. We find out if AB is fixed, then when you move the P around the circle, the angle will be not changed. So theta remains unchanged. Okay, when P moves around the circle. Okay, so it's always a constant same. So the special case is right above the center. Right, that's right above the center. So you connect. This will be also theta. Okay, it's the same theta. Doesn't matter where the location of the point, as long as AB fixed. Then one can show that this is actually is going to be half of the angle alpha. So theta actually is half of the alpha. Okay. How do you prove that this is half of it? Okay. Let's see if we're able to prove that or not. But it's not easy to prove the theta is always constant. Okay. When you point move around the circle, but maybe you can find a relationship between theta and the alpha when it's above right above the okay. So let's see what we can get, right? This is the theta. Okay. The reason is, okay, you can think about this. This two angle will be these two angles will be equal to that angle. Okay, right? So let's call the this because this is isosceles triangle. This is isosceles triangle. So those two angles will be same, okay, equal to this angle. Okay, and I'm going to call it yeah, let's call this theta 1. That's a theta 2. Okay, so then because this is an isosceles triangle, that's also theta 1. That's a theta 2. Okay, right? And then this will be alpha 1. This will be alpha 2. Okay, let's see. Okay, so you will see that alpha 1 is going to be twice of alpha 2 theta because this is the exterior angle. Remember the formula, right? This two angles, right? Alpha, beta, gamma. Gamma is going to be alpha plus beta. Okay, this is always true. Okay, so now your alpha 1 is because these two angles are identical, so it's 2 theta 1. Then similarly, alpha 2 is a 2 theta 2. Okay, so add them together. Alpha is going to be alpha 1 plus alpha 2. So it's not necessary to be just exactly in the center, right? So that'll be 2 theta 1 plus 2 theta 2. So you can add this two angle together, but those angle together is just 2 theta. Okay, so that's why alpha equals 2 theta. Okay, since alpha is a fixed, and so the theta always unchanged when you move this point P. Actually, when doing this proof, I do not assume P is just right above the center. Otherwise, theta 1 equals theta 2, right? Alpha 1 equals alpha 2. Now we do not assume that. You can move P slightly away from the center, the middle point. Okay, so you still this is true, right? Okay. Now I hope you remember how to prove that gamma equals alpha plus beta in this triangle. Okay. All right, so that's all we need. So as long as these 2 points A, B are fixed, then the angle at point P remains unchanged. Okay. The special case is you open AB form a strict line. This is where B alpha is going to be 180 degrees. So in that case, this is point P, right? This will be my theta. So theta should be half of alpha, which is half of 180 degrees. That is 90 degrees. So that means this is always a right angle. This is always a right angle. Okay. This is always right angle. So if the triangle is inside the circle and AB is a hypotenuse, AB is a one-sided triangle, then this must be right triangle if AB is a diameter. Okay, if AB is a diameter, then this must be right triangle. Okay. Yeah. So if AB is this straight line is passes through the center, then the triangle you get is the right triangle. Okay, right? So you have this is a special case. Okay, so let's take a look at some examples. Okay. So I have two circles. One is a small one, other one is large. Okay, those two circles intersect somewhere here. And I know two intersecting circles have the common chord with the length 24. So this is A and the B. So I know that AB is going to be 24 centimeters long. I also know that the radius R is going to be 13 centimeters. The longer one is going to be 37 centimeters. So I want to find the distance between two centers. Find the distance between two centers. Okay. Now to solve this problem, yeah, you needed to draw the line. So this is the distance between two centers. But that's not enough to solve the problem. You have to, yeah, you have to draw addition lines in order to solve find the distance between two centers. Right? So remember, connect the important points. I think the intersection points are important points. I just connect them. Connect them. Okay. Then also this is a point, right? So you get the bunch, and this is right triangle by the symmetry. So I think it's easy to solve the problem right now. Okay. The distance between two centers, C1, C2. Okay. Yeah, let's look at the triangle here. C1, C2. Right. I know the radius R, right? So 37. I know this is a 33. This is the radius. I know this side is going to be 12. I think you can find this side and that side by the Pythagorean theory once you draw all the lines. So x is going to be 13 squared minus 12 squared, which is going to be 5, right? Which is going to be 5. Then the y is going to be 37 squared minus 12 squared, right? I think that is a 35. Okay, those are the special right triangles. So the answer is the distance between C1 and C2 is x plus y, 5 plus 35, which is 40. Okay, it's a 40 centimeters long. So all I have to do is just draw a couple lines and you get the triangles, write the triangles, then you solve it. Right? You can apply the Pythagorean theory. Here we did not use any properties I mentioned at the very beginning. Okay? I did not use any properties of the circles. All right, my next problem. I have a larger circle. I cut 2 circles inside. Okay, this circle has capital radius. This circle is R. Okay, I know we assume that this is a given the ratio 2/3. Now I'm going to change the problem a little bit. Okay, so the ratio here is a lambda. It's called. Okay, so this is a lambda. So if lambda is small, the lambda is less than 1, right? Then you can shrink one circle and enlarge the other circle, or they are equal, right? What is the case when they're equal? When they're equal, you know, lambda is always between 0 and 1, right? Okay, when it's equal, so let's take a look at the special case. When it's equal, the special case, okay, when it's equal, then you get this 2, right? Okay, so this is going to be R, right? So let's see what is the remaining part. Okay, so the remaining part, the radius is going to be 2R. Okay, so 2R pi 2R squared is a whole circle minus pi R squared, but you have to delete 2. So the answer is 2, right? 2 pi R squared. Okay. So that tells you what? That tells you the area of the shared region in this case is equal to the area of these 2 circles, right? Right? So the area of the shaded region, okay, is going to be equal to the total area of the 2 circles, 2 congruent circles. Okay, in this particular case. Now, if you shrink one circle, enlarge the other circle, then are you going to increase the area or decrease the area? Okay. So what I want to do is I think it's going to increase the area, the total area of the circle. If you make it, you see, this is kind of design, right? So this is too big, right? So you will see that the shaded region, the area, is getting less and less probably, right? When you enlarge one circle, shrink the other circle. Okay, so my question is, the area is getting smaller from 2 pi r capital R square right? This is half of the circle. So I want to find the lambda such that, okay, the area shared region okay, is going to be a quarter, not as a half. This is a half of the third, right? This is half of the larger circle, a quarter of the area of the larger circle. Only occupies a quarter of the larger circle. Right. So the shared when you increase the one circle and shrink the other circle, and what the result is that the shared region, right, is getting smaller and smaller, right? So eventually shrink to zero because this second largest circle occupies the whole circle, right? Then no area of the shared region, zero. But when you shrink, when you gradually make two slit circles inside equal size, then you increase the area shared region to half of the whole circle. So we just solve this problem. Now to solve this type of problems, you all have to do is just find the equation in lambda, okay? Find the equation for lambda, okay? We may assume the largest circle has radius 2r, okay? So now here you have two circles, right? So these two circles are tangent to each other, right, in square. So the ratio, okay, well, if you may assume, the circle has a fixed size, okay, just 2, for example. Then you denote this circle and that circle later on capital. In that case, I needed to fix the radius. Let's call it, I cannot use the same capital R here, right? Right? So this will be, let's use a rho. How about like that, right? So, okay. So what do we got here? So 2r plus 2 kappa, right? It's going to be 2 rho. Okay, so rho is a fixed. So r plus this, okay, this is going to be rho, right? The diameter is going to be, the diameter of the largest circle is 2 rho. It's going to be the diameter of the small circle and the circle in the middle size. And we also know that the ratio is going to be lambda, right? So from here, you can solve for I little I and capital R, right? You can solve for little I and the little I is going to be lambda capital I, and they put it there. So you get lambda R plus R equals rho. So that implies capital I is going to be 1 plus lambda rho, okay? And the little r is going to be lambda 1 plus lambda rho, okay? So you calculate the radius 2, then the area of the shared region, okay? Okay, the area of the shared region, you can compute it, okay? Equals the area of the larger circle, the whole circle, right? We want to say this is a quarter, okay? So you get area shared region is a pi, okay? And this is a pi rho square, right? But the little r capital R can be expressed in just lambda, so it's going to be pi is cancelled out. So what you get here is going to be 1 plus lambda rho, right, square. That's capital. And then lambda 1 plus lambda and rho square. Okay, so rho square is also cancelled out. Okay, so what you get is going to be the quarter, and after you simplify, you get 1 plus lambda square and plus lambda 1 plus over lambda square. Okay, so you get a quadratic equation for lambda, then you can solve for lambda. So both sides you multiply by 1 plus lambda square. Okay, so 1 square plus lambda square. Okay, and then you solve the problem. Okay, so you can multiply by 4. So 1 plus lambda squared equals 4 plus 4 lambda squared, and you solve this problem. So it's great, you get a quadratic equation. Okay, then from here you solve for lambda. 2 plus minus b squared minus 4. Okay. Did I make a? Okay, wait a minute. Do I have a solutions? No, I don't have any solutions. So I have to double check. Okay. So there was a sign mistakes, I guess. Okay, let me go back. Otherwise, it's just no solution. You know, lambda cannot be 3 times 3. That would be negative. Okay. So then there will be no solution. So let's go back. Okay, to solve the problem. Lambda is actually lambda is a smaller number. It's less than 1. Okay. So this is a relationship, the proportion. Okay. And when lambda equals 1, that means that both circles are equal. When lambda is shrink, okay, then you have these two solutions. Okay. So that's almost my mistake actually. So what I got here is another ratio. I have to put this is the area, not the shared region. The area of the shared region is going to be pi. It's a difference, okay? That's why my mistake, okay? So that will be rho square minus this, okay? And after you cancel rho, that's just 1 minus that, okay? Yeah. Then I think the equation will be slightly changed. I think this will be, let me erase this, okay? Otherwise, I might I made yeah, see, at the end, I have no solution. That's why that was a mistake, okay? All right, so now from here, you will get how to solve the equation. Right, and that is going to be, yeah, this equation, I don't need it. Right, solve this quadratic equation, and this will be 3 over 4. Then you have this problem. Okay, you move this to the right. So you get 1 plus lambda squared equals 3 over 4, 1 plus lambda squared. Then you multiply both sides by 4. That's 4 plus 4 lambda squared. And the 3, 1 plus 2 lambda squared. Okay, so it's going to 3 plus 6 lambda plus 3 lambda squared. When I move 3 lambda squared to the left hand side, you get lambda squared minus 6 lambda plus 1. Okay, now you solve, you have the solution. Lambda equals 6 plus minus 6 squared minus 4ac. Okay, so you get 6 plus minus 36 minus 36 minus 4 is a 32. Right? But anyway, this is when you choose lambda should be less than 1. So the answer lambda should be equal to 6 minus square root of 36. Okay? Otherwise, it's bigger than that's the one. Okay, lambda must be smaller number. So you determine the number. Okay, you can simplify a little bit. Yeah, you can simplify a little bit. So you can get, 32 is going to be 16 times 2. So it's going to be 6 minus 4 square root 2 over 2. Then both sides divided by 2, right? Both times. So that is answer. Okay, it's less than 1, this number. This is a good question. Sometimes when as an engineer, you have to design things, right? You want to make sure that you want to make sure this shared region is about quarter of the whole circle, right? Area of the whole circle. So you have to put 2 circles inside. So you want to see what is a ratio of those 2 radius, right? Then you can cut it. Then the remaining part is going to be the area, 1/4 of the area of the whole circle. See, this is the application of mathematics, and you can solve that. Okay, that's a good question. All right. So our next problem is as follows. We have a isosceles right triangle. Okay, this is an isosceles of right triangle. Okay, right triangle, and this is an angle here. All right, and this is going to be A, B, and C. So that means A, B equals BC, right? Right, and there's an angle at the B is going to be 90 degrees, right? All right, and I also know that AC is going to be 24 centimeters long, the bottom part. So I'm going to draw a circle. All right, I'm drawing a circle passing through these 2 points. All right, so I got 2 intersection points, and this is another point. So what I want to do is I want to find the area of this region. Right? Yeah, area of the shared region. Right, we have to do some calculations. All right. My hint is this shared region must be a square, but explain to me why this must be square. So then all I need is to find the edge length of the square. Then you can find the area, right? Okay, so you have to explain why this must be a square. Once you know it's a square, then you probably can find the area. Okay. Anyone has ideas? Yeah, let me draw the picture again. So this is a 45 degree and a 45 degree, and here's a circle. Oh, sorry, this is not a circle. That's not look like a circle. I maybe use a tool here to draw the circle. Where is circle? Okay. Oops. Huh. Okay, I'm going to move to this side. And this is circle. All right. All right. So first of all, yeah, by symmetry, it's in the middle. So this is perpendicular, right? Now, this is a diameter. Okay. So here's a B, this A, and the C, and the P, and then okay. So B and the P is a diameter. So that implies D and the E. So if we connect them, this angle must be 90 degrees, right? We use a property, and this angle must be degree, right? So since here must be 45 degrees, right? And this must be 45 degrees, this must be 45 degrees. Therefore, this is also right angle. Now this is right angle, and why this must be square? Why this must be square? Because BE equals PE, right? So that's the reason it's a square. Otherwise, this is and also an isosceles triangle. Okay. So this is a square, and clearly BDPE is a square, and then if you use this property, you can figure it out. Okay. Yeah. So this side PC, we know that we are given, right? PC is going to be 12, right? So if this side is A, this side is A, right? So A, come on, Alex, we are talking about the area of the shared region. Okay, it's not a circle. There should be no pi there. So A square plus A square equals 12 square. Okay, right? Right? A square plus, and the area of the square is just A square. It's 12 squared divided by 2. So which is 144 divided by 2. Hold on. Yeah. Yeah. So the area of shared region is this, right? Okay. This is a square, so it's just A squared. It's 100. This is 72. Right? 72, yes. So A squared 72, that is the area of the square inside. Okay, that is the area. Okay. Now we come to another problem. This is a mass context problem. So I draw a random line. Okay, I draw a random line. So I get AC intersections P and the D and the B. Okay, A, B, and C, D, and P intersect at this point. All right. So what I'm going to have here is I have a 3 and 4 and 5. I want to find the PX. Okay, PD equals X. What is that X? All right. I'll give you a minute to think about. So you have to draw some addition lines, okay? People telling you for geometry problem, you cannot just sit there. You needed to draw addition lines, connecting important points. Then you probably figured out how to do the problem, okay? Okay, let's do it. Okay, a couple of you. Alex, I already have my answer for that. Hi, so I get several different answers. Okay. Let's see. I'm going to connect important points. I use my red pen. Okay, 1, 2, 3, 4. Okay, then what? So there are some triangles similar. Okay, so how can I see that? Right? I don't need so many triangles. I have 4 triangles here. I just needed to compare those 2 triangles. I'm going to color it. Okay, one triangle is here, other triangle use a different color. Okay, I want to say those 2 triangles are similar. Similarity. Why these 2 triangles are similar? You have to find the corresponding angles that are equal. Okay. This triangle, let's call the theta. Okay, theta. Okay, that's a definite identical, right? Then I claim the angle here, alpha, is the same angle as this one. You know why? Because they have the same foot points, A and D. Okay, right? You have a look at. If you don't see it, I'm going to redraw the picture again. If you have this, right? Okay, this is I told you, this will be alpha, then this must be alpha because A, B are same, A, B. Okay, it doesn't matter where's the location of this point. B and C. If you move B to C, then you get the same angle. Okay, and similarly, this is a beta, right? And this is also beta. So those 2 triangles are similar. So I triangle say A, P, C is similar to A is a D here right now. This corresponds D, P, and the B. Okay, so the ratios of corresponding sides are equal, right? So that means 3 over x is equal to 4 over 5. Okay, that's why. Yeah, this is the 2 triangles here, right? 3 and 4 has the x and the 5. So those 2 sides are corresponding to each other. These 2 sides correspond to each other. So that's why 3 over x equal to 4 over 5. So x is going to be 3 times 5 over 4, 15 over 4, another 20 over 3. I think Alex did not mark the corresponding sides. Right. Okay. Right, this should be 15 over 4. Right, so next problem, I want to try is I have a circle again. This is a center, right? And so I have a triangle. Right? If the perimeter of the triangle is going to be 60, what is the area? Right. So if you know the perimeter of the triangle, you inscribe in the circle so that one side is on the diameter. Then if you know the perimeter, can you figure out the area? Right? You maybe you can figure it out, maybe not. Okay, maybe not sufficient enough information. So you try this again. Okay. There's not enough information, you think. That's not enough information. But, but I know what I know is okay, I should know some information, right? The parameter. Okay, so let me give you more information. So if you know the radius, okay, it's gonna be 13. How about like that? Right? If radius. Right? Can you solve the problem right now? Yeah. Nancy says you cannot solve it, right? Without this information. Yeah. Well, I'm going to show you. We assume that the I is not given, right? So what are you going to do? This is a right triangle. So I'm calling this side X, this side is Y, okay? We know that X plus Y plus 2R, the radius, right? It should be equal to 60, okay? And we also know this is a right triangle, okay? So the area of the triangle is going to be X times Y, okay? Right? Divided by 2. Any other information we need? I think this is a right triangle. So x squared plus y squared equals 2r squared. Okay. But based on this information, you can determine, x times y? Okay. The answer is, okay, x plus y minus 2i is x total, right? And then x squared plus y squared equals 2r squared. So it really depends on the radius, right? All right. So can I get x times y from this two? The answer is yes. X plus y squared is going to be, okay, it's going to be x squared plus y squared plus 2 times xy. So the left-hand side is 60 minus 2r squared. The right-hand side is 2r squared, then plus 2xy. Yeah, okay. Yeah, you can do subtract. So from here, you get x times y. You don't need to find x and y individually. So you get 2xy equals 60 minus 2r squared, right? Minus 2r squared. So when I square it, I get 60 squared. And twice of that, 240r, right? Yeah, plus 2r squared minus 2r squared. So canceled out. So x times y, the area is divided by 2. I have to divide by 4 both sides. Okay. So that the area depends on the radius of the circle. If we change the radius of the circle, we change the area, of course. But you still can manage it, keep the same parameter. I think that's the problem here. So there, yeah, there's a possibility. You keep change. Yeah, you can make the parameter unchanged, even you change the size of the circle. Okay, that's the reason. And the area be changed. That's the reason you cannot determine the area of the triangle. Right, so the area triangle depends on the radius from here. I cannot determine the radius based on the given information. Right. So if you know the radius, then you get the answer. Okay. So there's always a hidden equation there if you know this is the right triangle. If you know this is the right triangle, the Pythagorean theory gives the hidden equation. All right, so our next problem is a circle here again, and this is the center, okay? And what I'm going to do is I'm going to, yeah, Here's E and C. And then take a point A here and then draw a rectangle. Okay, this is a rectangle. So EC equals diameter equals 5. And this side, I know AE equals 3. I want to find the area of the rectangle. Okay. I think the rectangle is uniquely determined, and because AE in general, without says okay, AE, EC is a diameter. Okay, half of EC is going to be no, that's I think it should be on the other side. So yeah. So A is 3, right? And so it's not A is not right above that. Okay, if A is right above the center, then that'll be 5 square root of 2, which is much larger than 1/2 times square root of 2. Yeah, it'll be larger than 3. Okay, so we here yeah, the special case. Okay, the special case here. Okay, what do you get? It's a 5 over 2, 5 over 2, 5 over 2. So this side is going to be 5 over 2 times square root of 2, right? Okay. So that is going to be 5 over square root of 2. And this number is definitely greater than 3. Right? Why greater than 3? You can square them both sides. Right? You square them both sides, you will get 25 greater than 4 times 18. Yes. Okay, so this side, the special, so when you have a 3 means somewhere here, it's getting shorter, right? And short when you move the point. So this is a 3. Okay. All right, so can you find out the area of the rectangle? Yeah. Yeah, for the above problem lesson, yeah, I give you the radius, okay? If I don't give you the radius, your answer will be, the area depends on radius. Okay, now here, the circle is fixed. The radius is half, it's 2.5. Okay, then you get, you draw the rectangle. So this is a rectangle. Okay, find the area of rectangle. In order to find the area of rectangle, what do you need? I think you need to find the y, you need to find the x, right? Then x times y is the area of the rectangle. We have to use a property, the triangle inside the circle. So you needed to draw another line, right? This will be the diagonal of the rectangle also, right? So what is the length? First of all, you figured out AC. AC by the Pythagorean series of 5 squared minus 3 squared is 4. So AC is going to be 4. then that's probably enough. Then you get x squared plus y squared equals 4 squared, right? But that's not enough. We want to find x times y, all right? What else? We haven't used, yeah, let's try, yeah. And yeah, trying to write down the equations. Here's a 5 minus x, right? 5 minus x. So you can apply the Pythagorean theory to that triangle, right? Yeah, where's my equation here? X squared plus y squared equals 4 squared. That's the first equation. Second equation, 5 minus x squared plus y squared equals 3 squared. I think I can determine x and y. Then you find the product, right? That's one way to do it. Another way is that you can use the area to find the y first, because the area is a triangle. Okay, you know the other side, right? Okay, so the area is a triangle. Yeah, let's go back to the picture again. Here's a 5, that's a 3, that's a 4, this is a y, right? So using the area as a triangle, then you get half of the times the y, that's the area of a triangle. That would be half of 3 times 4. I think y equals 12 over 5. Okay, once you get y, then you can get an x, right? Okay, then you can get x. Okay, and then you look at the product. So x is going to be square root of 4 squared minus y squared, right? 4 squared minus 12 of 5 squared. So let's simplify it. All right, so what is that? If you don't want to use a calculate, then I think you can take a square, take a 4 square over 5 square out. And then it will be 5 square minus 3 square. Okay, 5 square minus 3 square is going to be 4 square. Okay, so that is 4 square over 5, 16 over 5. Right, so that's it. And then the area is going to be the product of these two numbers. Okay, it's going to be 192 over 25. Okay, you can also solve for x and y from above two equations without using the area of the triangle. Okay, let's go back to this problem. Okay, you look at the picture here. This is a 5 minus x. So you have two equations, x squared plus y squared equals 4 squared, 5 minus x squared plus y squared equals 3 squared. And from here you can get x immediately, solving those two equations. And you get x, then you can also, once you get x, you can get y. Yeah, you use a subtraction. Yeah, equation 1, equation 2, right? Those two equations. You take a subtraction, equation 1 minus equation 2. So x squared minus 5 minus x squared equals 3 squared minus 4 squared minus 3 squared. Y is gone, right? Then from here you solve for x. Okay, so x squared minus 5 squared minus 10x plus x squared. Okay, so you get x squared is gone, negative 25 plus 10x, 16 minus 9 is 7. Okay, so 10x 25 plus 7 is going to be 32. Okay, x is going to be 32 over 10. That's a 16 over 5. It's the same answer, right? It's magic. Okay. So once you get, yeah, this is another way to solve the problem. Yeah, once you get x, you can get a y. Okay. So here we find the x. We also we find the y first, then find the x. And over there we find the x first. All right. So just to list all the given information, then you can solve the problem. Okay, so very last problem. I don't have enough time to discuss all the problems, so you will get my lecture notes of the problems I want to discuss in the class. You can read it. Okay, so this is a square. Okay, this is a square. The edge length, I'm just assume that the edge length is going to be, I can assume that's going to be 4, okay? Doesn't matter. So I choose a middle point, I connect them. This is the middle point. Okay, then when I choose a middle point, I can have a, okay, then I can find the largest possible circle inside. Okay, find the radius of the circle. This is a circle, it's inscribed in this square, but not, sorry, I did not draw it. So find the radius, okay, of the circle. It touches 3 points here, right? And how do we solve the problem? Well, I said that you have to draw many draw the lines. Okay, so you draw the lines, addition lines to use the red cards. The lines coming from here to here. That's not enough. Then this is a center, right? So you get those. All right. I don't know the radius, right? But you know that this is a middle point, so it's 2 and 2 here, right? And how about this piece? This piece is 2 divided by square root 2. Actually, this is a square root 2, right? Square root 2. Okay, so this is a radius r. If this is r, right, this is a right-hand triangle, so this part is square root 2 times r, right? So square root 2 plus r plus square root 2r, total, that should be equal to 4 square root 2, because the length of the diagonal of the square is going to be 4 square root 2. Immediately you solve the problem, okay? So you get 1 plus square root 2r equals 3 square root 2, right? Then from here you find the radius. It's not going to be a rational number, it's irrational number, okay? But then we have found an answer, okay? You can rationalize the denominator if you want, it's a good exercise. Yeah, so you can do it. Okay. So you will multiply the denominator is a square root 2 square minus 1, and the 3 here, square root 2 times square root is 2. Right, the square root 2 times 1 is square root 2, and the numerator is just the denominator just 2 minus 1, it's 1. So this is a positive number, and that gives us the exact value of the radius. All right, remember, you have to draw addition lines to understand the geometry problems. If you really don't know at the very beginning, just draw as many lines as possible, connecting the important points. Then sometimes you will see the right triangle, then you can apply the Pythagorean theory to the right triangle. Okay, so I'm not able to discuss all the problems, but there are some other good examples I mentioned in my notes. You can take a quick look if you have trouble with the homework. Okay, that's it for today's class. Stop here.